to dear children. Hope all of you are fine and safe. So today we are again here, back here with the continuation of our online classes. And today we'll start with a new chapter, current electricity. So before we start with this, before we go to this chapter, let us discuss about the word electricity. Now this electricity plays a very important role in our life. Now what important role they will play? They light our house, they runs all the electrical gadgets, electrical equipment, okay, they charge mobile phone, they charge batteries, okay, we can be able to watch television, we can be able to operate all the mobiles or laptops, everything. So with the help of electricity we are doing all these things. So therefore electricity is considered as a form of energy. They play a vital role in our life and they are regarded as a form of energy. So two types of electricity are there. One is a static electricity, which I have already discussed in the previous class. Another one is a current electricity, which we are going to deal with. So let us discuss about the difference between the static electricity and the current electricity. Now in case of a static electricity, the charge means electrons. The charge do not flow. There will be no flow of charge in static electricity. After all, both are electricity, static electricity as well as current electricity. They are both electricity. They are considered as an electricity. But once electricity, that is a static, in static electricity, that there will be no flow of charge. The charge remains stationary. Whereas in current electricity, the charge will flow. So charge means the flow of electrons. And the flow of charge in a conductor constitute electric current. So in order to make the current to flow, there should be the flow of charge, there should be the flow of electrons. So the first difference is, in a static electricity, the flow of charge remains stationary. In current electricity, there is a flow of charge. Second difference, it occurs in static electricity, it occurs both in conductor as well as in insulators. That means they occur in conductor also as well as insulator also. Whereas in a current electricity, they occur only in conductors. That means there is a flow of charge only in conductors. The third difference, in case of a current electricity, it does not require electric circuit to flow. Okay, in order to produce electricity, it does not require electric circuit. So electric circuit means it is a path in which the current flows. Okay. Now path through which the electric current flows means, example I give you, a switch, a wire, a bulb, a battery or a cell, all these constitute as an electric circuit. If they are connected, okay, if you have got only a wire and a bulb, no source of current, the current cannot flow, the electric current, the bulb cannot glow. So in order to make a bulb to glow, there should be a battery, there should be a wire, there should be a bulb, and all these things should be connected with each other. Then only the current will flow. So therefore, these are known as the electric circuit. So electric circuit is a path in which the current flows. So in static electricity, electric circuit is not required. That means the flow of current, the path in which the flow of current is not required in static electricity. Whereas in a current electricity, the electric circuit is needed. Another one, lightning is an example of static electricity. Lightning is an example of current electricity, whereas in a current electricity, the electricity which is obtained from the battery is an example of electricity. Okay, that means the electricity which is obtained from the battery is an example of current electricity. So these are the difference between the static electricity and the current electricity. Now when we discuss about this current electricity, first of all you should know about the conductor and insulator. Okay, now this conductor, these are the substances through which a current flows. Okay, that means all the metals, they are the good conductor of electricity. Now in a conductor, there is a presence of free electrons, and the presence of free electrons denotes whether the substance is a conductor or an insulator. Okay, I already have discussed about the free electron. Free electrons is also known as the valence electron. So when the electric current is produced, there should be the flow of free electrons which are present in the conductor. When the electrons will flow in a conductor, and that flow of electrons will constitute the flow of electric current. So now there are the two things that you should remember. One is a conductor and other one is an insulator. Okay, and also the two types of charges are there. One is a positive charge, other one is a negative charge. And the two types of charges are proton. One is a proton, that proton carries a positive charge and the electron carries negative charge. And when the current is produced, or when there is a flow of current, the flow of current is denoted by the flow of electrons. So therefore we can say, when we discuss about the word current electricity, so current electricity means the flow of electrons. The flow of electrons constitute the flow of current. So where these electrons will flow? The electrons will flow in a conductor. Electrons will flow in a conductor, not in an insulator, because current electricity, in current electricity, the current electricity will be produced only when there is a flow of electrons, and this flow of electrons takes place in a conductor. Now, when we consider, let us consider a conductor. Okay. So in a conductor, there are plenty of free electrons, and these free electrons will move randomly in all the directions. These free electrons will move randomly in all the directions. So that means you can see in the diagram here. Okay, these are the electrons and these are the protons. Okay, positive charged ions, which we call it as a proton. So now this entire part is a conductor here. Okay, so in a conductor, there are the two terminals are here, the two portions are here. One is a positive, other one is a negative. Okay, so the negative part comprises the number of electrons are more. Okay, and the positive side, the number of electrons are less. So when we consider a conductor, okay, and in a conductor, what happens is that now these electrons will move randomly in all the directions. So when they move randomly in all the direction, what will happen? They can move randomly. But when these electrons are drift in one direction, first these electrons can move randomly in all the directions. Now the flow of electrons can be made only in one way. That means to make that drift of electrons, to make the flow of electrons in one particular direction, now let us consider this conductor is joined with a wire, and these are the source of electric current. Okay, so positive and negative. One long vertical line represents the positive, and the short vertical line represents negative. Okay, so these are the cell, we call it as a cell or a source of electric current. Now this is connected with a wire. Okay, and this is a conductor. Let us consider a copper. A wire is a conductor. So in a conductor, there are plenty of free electrons are there, and these free electrons will move from the negative part of the conductor towards the positive part of the conductor. Okay, now before that, the electrons are moving randomly in all the directions. You can see this here. They are moving randomly in all the directions. Now what happens is that now when these electrons are now connected with an electric circuit. Electric circuit means now some part has been made in order to make the flow of electrons here. Okay, by connecting with a wire, with a battery, with a cell. Now these electrons will drift in one particular direction. Okay, so they will move. And when they will move is they will move from the negative terminal of the conductor towards the positive terminal of the conductor. So this is a negative, this one is positive. But before that, though they are moving, before also the electrons are moving from negative to positive, but they are moving randomly. But now some particular direction has been made. That means now they get drifted in one particular direction. So when they get drifted in one particular direction, okay, now these electrons will move in a particular direction from negative terminal towards the positive terminal, which we call it as a convectional direction of current. So convectional direction of current means the flow of electrons. Convectional direction of current, which is taking place here. And when there is a convectional direction of the current, that gives the flow of electric current. So the electric current now will flow when there is a flow of electrons. Okay, so unless and until if there is no flow of electrons, if there is no convectional directions of the current, the electric current will not be able to produce. There will be no flow of electric current. So these electric current are formed due to the flow of electrons from the negative terminals towards the positive terminals. Okay, and the flow of current takes it in the opposite direction. That means from positive to negative. The flow of electrons are taking place from negative to positive, whereas the flow of current are taking place from positive to negative. So this way the electric current are produced. So therefore we can say that electric current are produced only in a conductor. Okay, and whether the substance is a conductor or an insulator, it depends upon the presence of free electrons. So in conductor there are plenty of free electrons, and the free electrons will drift from the negative terminal of the conductor towards the positive terminal of the conductor. So when there is a flow of electrons, then that gives the flow of current. So this way the electric current are produced. Thank you.